Welcome back, everybody. We're going to get going with our early morning keynote, our plenary session. I am again pleased to introduce the President and CEO of EOCP, Kalpana Solanki.
Thank you. Good morning, everyone, and welcome to day 2 of EOCP 2021. And for those of you joining us for day 2, welcome back. And for those of you joining us just for today, I'm so glad that you could be here with us. Just a few notes. Some of this is going to be a little bit repetitious, maybe. I mentioned yesterday about my fondness for Terminator movies and science fiction and things like that. Can't wait for the new Matrix movie to come out. December 22nd, 2021. Anyway, 6 rules for success. I had to quote this from Arnie because this is kind of how we do things at the UCP. And also just wanted to highlight again some of the work that we've done in the last few months with our strategic priorities. We sat down and it was a very interesting hybrid session with some people in the room and some people joining us remotely, board directors, staff members, major stakeholders, including people from the Ministry of Health, Ministry of Environment, and Ministry of Municipal Affairs and Housing, as well as some former board directors. So a really good, diverse group of individuals. Just to kind of end things, tell you a few more things. Am I missing a video? No, I'm not. So we have actually, I made this slide up a little bit earlier, but we actually have 565 delegates registered for this conference. So really thrilled about that. And sorry, I'm just trying to see here. Thank you to the team, the EOCP team, Heather Reynolds, who introduced me, Kim Eames and Stephanie Hall for helping pull all of this together, to our directors for moderating the sessions, to the AV team, Encore. They've been troubleshooting and working with us, and rehearsals and schedule changes, all kinds of things, and they've stayed on top of it. And I don't know if any hotel staff are here at the Marriott Pinnacle, if any of them are in this room, but a huge thank you to them for taking such good care of us, including chasing down some of the team members who hadn't eaten to make sure that they got their meals because everyone was so busy with the conference. One of the other things I mentioned yesterday was 2 videos that we have ready. I showed one yesterday. I'm going to show the second one today. We have 3 or 4 more in the works, and we will be releasing these as they get ready, and they will be available as promo materials for any utilities that want to use them for when kids come in for field trips and so on, so you can show them what operators do, the kind of work that operators do. We will be also having these available at our website. We will be using them for our presentations and also going out to various groups and promoting the work, the very valuable work that operators do. So if you could roll the video, please, from Sonia Kustock, City of Langley.
There's always a way that we can do all of the exact same things that everybody else does. There's absolutely no reason that women can't do the work that I do. Hi, I'm Sonia Kustock. I'm a water distribution and wastewater collection operator with the City of Langley.
Sorry, a bit of a technical issue there.
My job is to problem solve any issue.
We'll just play this from the start in just a minute.
There's always a way that we can do all of the exact same things that everybody else does. There's absolutely no reason that women can't do the work that I do. Hi, I'm Sonia Kustok. I'm a water distribution and wastewater collection operator with the City of Langley. My job is to problem solve any issues that may arise within the wastewater collection system. I love my job because every day is different. Every day there's a new problem, a new solution. It's exciting. You have a chance to develop and learn coming across different situations. Working for the city is absolutely fantastic. All my coworkers are incredibly supportive. They're like my family. We work as a team and I'm just part of the team. It's incredibly satisfying every day to come to work and have a purpose or have a problem and be able to solve it and know at the end of the day that you solved the problem, so it's not going to happen anymore. And there's definitely a feeling of accomplishment knowing that you were able to do those things. My name is Sonia Kustok. I'm a water distribution and wastewater collection operator.
Okay, thank you very much. So as I mentioned, we're going to have 3 more videos in the next 3 or maybe 4 more videos in the next little while. And we're really thrilled that the operators have volunteered for this project. Before I hand things over to our board chair, I just wanted to give you a few stats. We had really good response rate for the end of day 1 conference survey. And I just wanted to let you know some of the feedback we've received from you. Question number 1, the conference day met my expectations. 97% either strongly agreed or agreed. The conference day was well structured. 98% strongly agreed and agreed. I would be interested in attending the EOCP's conference in September 2022. 98% agreed or strongly agreed. And really hoping that 2022 we will have a conference in person at the Marriott Pinnacle in Vancouver, and 64% of the respondents who said they're interested in attending the conference next year said that they would like to attend the conference in person. So without further ado, I am going to hand things over to Chris Lawrence, the chair of the board of directors of the EOCP.
Good morning, everyone. Welcome to day 2 of the 2021 EOCP conference. I don't know if that song's quite fitting, but nice job, Heather. I hope most of you were able to attend yesterday. There were some fantastic sessions, and it was just a really nice day to kind of kick off the conference. So this morning, before I introduce our plenary session, I just wanted to go through a few things and thank everybody for attending this conference, and just kind of highlight some of the things that we're working on here with the board on the EOCP. We're looking for some more representation with small water and wastewater systems. So we've had some pretty good discussions about how to achieve that, and we're going to be looking at amending our constitution and bylaws. So anyone who's an EOCP member can look forward to that in June, and I'm sure we can get some more details out on that. I'd also like to point out that there are many people in attendance, just like Keltna said, but I think we need to highlight too that there are also people from out of country as well. And from my knowledge, we have people from Idaho attending this conference, so we'd like to say welcome. So without further ado, I would like to introduce Dr. Andrew Welton. Andrew Welton is a Purdue University professor of civil, environmental, and ecological engineering and is a nationally recognized environmental engineer with 20 years of experience in infrastructure, public health, and environment areas. At Purdue, he leads the Healthy Plumbing Consortium and Center for Plumbing Safety and other initiatives with multiple university and industrial collaborators. In recent years, his teams have unearthed previously undocumented and fatal human health and environmental threats associated with plastic manufacture. His teams have also responded to support communities devastated by wildfires. Over the past 2 decades, his teams have positively changed how government agencies and water utilities, nonprofit organizations, health departments, state legislatures, and building owners approach their responsibilities. So please welcome Andrew today.
All right, great. Well, thank you so much for the lovely introduction, and thanks for zooming me in here from Indiana, USA. It's about 80 degrees here, and we just had a heat wave, so I hope it's a little cooler there. I am going to talk for the next 30 minutes or so about wildfire effects on potable water systems, and probably not what you're thinking. Many people who think about wildfire impacts on potable water systems think about burn damage to the watershed and water treatment issues. I'm going to focus on the water distribution system. When your watershed may not be affected, or that's not necessarily the issue that you're most concerned about. As the speaker mentioned, we do a bunch of things here at Purdue University. Disasters and wildfires are some of the focuses of what we work on, but a lot more information can be found on websites that I'll give you later on. And when it comes down to it, for wildfire-caused water contamination, this is where we're focused. We're focused on the water distribution system, the service lines, the water mains, the hydrants, the valves, going up to the water meter, and then entering the private property, whether it be by a business or individual landowner, going into the buildings. And so in the US, down south here, we have natural disasters that are affecting us all the time. But in recent years, in the last 15 years, we have focused on the guidance that's been issued after these disasters and how the decisions are made when people are trying to respond to and recover from these disasters, where chemical contamination or microbial contamination is caused in water distribution systems. One of the complexities of this, though, in here I'm trying in the introduction to set the stage for what I'm about to show you, is that in water distribution systems, and even building and plumbing, there's a number of different materials that are present. These might be metal pipes, these might be plastic pipes, a whole bunch of different types of plastic pipes. You might have sediment or biofilms and other types of materials. And when we have chemical contamination of a water distribution system, whether it's 7 miles in length, 2 miles in length, or 3,000 miles in length, you need to have some idea about where the chemicals are going to go. And that historically really hasn't been addressed because generally people have assumed that water distribution systems won't get contaminated. And you'll always have that multi-barrier approach where you can treat the water before sending it out to the distribution system. But the issue that I'm going to talk about is where distribution systems themselves become contaminated, and you don't really have that multi-barrier approach before the water gets to the customer. Another issue that's kind of reared its head during wildfire disaster responses is building plumbing. In building plumbing, as we know from the COVID pandemic, and trying to make sure that these low water use or shut down buildings are brought back safely, and so the plumbing doesn't harm people due to the growth of Legionella or other chemicals, there really hasn't been work in that space either. But when disasters contaminate entire distribution systems, and that contaminated water is then pumped in through buildings, you have to start thinking about those materials too. You have to understand what materials are there, what volumes are there, what flow rates are in those buildings. And over the years, we've started to put some information together about these types of materials. Now, if you've ever been to an area that has been impacted by a wildfire, whether it's a public water system or somebody on a private well, you'll notice that, it's not just the mailboxes and the homes, but it might be the irrigation systems, it might be other plumbing or water system components in the area that are impacted as well. And so considering all these different factors when you respond to these incidents is very important, whether or not they're damaged, whether or not the damage causes contamination, and then if it did cause contamination, where did that contamination go, and did it contaminate anything else? So about 10 years ago, I started working on this after moving on from the U.S. Army position I had. And what we found out 10 years ago in the U.S. was that a lot of the flushing protocols that utilities and public health departments and state agencies were telling people to use after contamination disasters actually weren't agreeing with each other or based on plumbing design and understanding. And so over the years, that's what kind of set us off on this path to help utilities and health departments better understand what to do. And just to kind of give you some idea, some of the flushing protocols assume that chemicals, whether they be, gasoline or lead or antimony, when they enter, a water system, they didn't react with anything, regardless whether you had a plastic pipe or metal pipe, and that just is not true. And then some of the other issues too we identified after a chemical spill in West Virginia. There was a very well-known activist that you would probably be familiar with the name, running around with their team telling people that they will have to pump soap into their water heaters after the disaster to clean them. And there was an organic chemical that was in the plumbing and in the water utility distribution system. And thankfully, many people didn't do that, but some did and called me and told me that their plumbing was leaking and that they had to get it replaced. And it was primarily because the chemical basically interacted with their plastic gaskets inside their plumbing and caused leaking. And so here's kind of like the state of the science about 5 to 10 years ago. So that kind of brings us to wildfires. And, it's important to recognize that in wildfires, in the U.S. at least, 4 of the 5 largest in the U.S. occurred in 2020. But the deadliest and most destructive did not occur in 2020. Actually, the deadliest and most destructive occurred in 2017 and 2018, the Tubbs Fire and the Camp Fire. In California, just alone, one of our states, 2.7 million people live in very high fire hazard severity areas. And that was, back in 2020. This year, we have about 5.5 million acres burned, and many of them have been the largest fires in the last 10 years now, have occurred this year. Thankfully, we haven't seen any type of the fatalities or just the structure damage that we've seen in other years. But as you know, because Canada has experienced several dozens of wildfires, some of them have been quite significant and even made the national news. There has been heartache and devastation to infrastructure in communities. Outside the U.S., right, it's not just a North America thing. Outside the U.S., in Greece and Turkey and elsewhere across the world, there are wildfires that are affecting communities, but many of them are not mentioned. So to kind of give you, the bottom line up front, wildfires can contaminate drinking water distribution systems, and it's done so by 3 major pathways. And the bottom line is that you can get hazardous waste scale drinking water chemical contamination in the water mains and service lines. And that has been detected in the US, in Oregon and California. And the first detection kind of was in 2017 after the Tubbs Fire, when the city of Santa Rosa did testing and found very, very high levels of benzene in the water. So in the US, our long-term MCL, or maximum contaminant level for benzene, is like 5 parts per billion. The short-term exposure limit that California determined could cause blood chemistry changes in children is 26 parts per billion, and they found 40,000 parts per billion in Santa Rosa, California's drinking water distribution system. Now, year later, the campfire occurred and testing again was conducted, and they found, pretty, very, very high levels. Actually, 2,200 parts per billion was found in Paradise, California. 530 was found in another water system. And since then, water utilities have been doing testing to try to figure out, after a wildfire, if they lost pressure, if they have plastics in their plumbing or infrastructure, or what chemicals are present. And so it happens. And prior to 2017, the reason why there's no data is because nobody was testing. So I guarantee it happened before, just people didn't know. So after the Tubbs fire and the campfire, we kind of compiled all the data together and we published it. This is freely available. You can download it online, and I'll put a copy of this presentation on the website at plumbingsafety.org, so you can access and download it. A lot of lessons were learned there. But basically, we got called in after the campfire because I had helped Santa Rosa with the Tubbs fire just peripherally, and they didn't understand why they couldn't flush out all the contamination after 3 months of flushing, 7 miles of their system. And it's because of plastics. And so certain plastics that you can have, like high density polyethylene or PEX, actually act like sponges. You can soak up these VOCs and then leach them out slowly over time. And slowly means months to potentially years, depending on the scale of contamination and damage. So I was called by Santa Rosa as they were recovering, and then Paradise called Santa Rosa and said, who do you recommend that comes in and helps us with this? So we went in at Purdue to help Paradise kind of figure out what was going on, but it actually turned into this much larger issue where the state of California didn't necessarily have the people with the expertise on hand to kind of understand what to do. FEMA was there, federal agencies, US EPA was there, CAL FIRE, all sorts of different organizations were there that we kind of helped pull together and kind of get them, on a path to recovery. But basically, after the campfire, about 96% of the structures in the town of Paradise were destroyed. But what you don't hear much is the surrounding communities. And so I put some numbers up on the screen in red. That's how many structures were destroyed for these separate water systems or their customers. So, Paradise wasn't the only place that was affected by it, but you might have heard the most about it. So when we showed up 3 days after the getting called, so we showed up, and about 3 months after the fire, and we kind of put everything in front of us. And what we found out was the both major utilities in the area only had like less than 50 water samples to their name after that. And so, town of Paradise has 172 miles of water mains, 16,000 service lines, and some of the other utilities were pretty big too. And so the reason why is because many of the utility staff had to take their families away and get them set up so that they could basically live comfortably and safely. And that's the first priority, right? Saving lives, saving property, and then figure out what's going on. So we helped the town of Paradise and the utilities and everybody kind of design a plan, isolate the system, try to repressurize it, test it, wait for stagnated water to sit there for 72 hours, because just like a sponge, right? Take like red dye on a yellow sponge. If you let that sponge sit in the red dye for a long time and you take that sponge out of the water and put it in clear water, it's going to take a lot longer for that red dye to come out because it's been sitting there soaking for a while. It's the same concept you have to apply for sampling here. Like, you just can't take a water sample and assume that will tell you what the worst case condition is for that system. It's kind of like lead sampling, right? When you sample for lead in drinking water, if you pre-flush the plumbing or you pre-flush the faucet, you don't necessarily know what the exposure is going to be. And because of that, you you can't actually predict or determine if the plumbing needs to be addressed. So here's some pictures here that you've probably seen. 90% of their 172-mile water distribution system was depressurized for weeks. And they had a map like this. They did have a model, water quality model, that one of their consultants started to work on. But, you know, truth be told, when you have hundreds of leaks and complete depressurization, your model is really not that helpful. Because you need, situational operational awareness. And this is where your superintendent of distribution, your operators who know where everything is and what to do is critical. And so this picture here shows just a map of their service area in the town of Paradise. Any of those colored dots indicates that there's a standing home. And all around it, and you can kind of see here, cul-de-sacs and streets, there were homes up and down all those streets, but all these dots indicate where the homes were left standing. Everything else was destroyed. And so there was about 11,000 pictures that looked like this. Now, one of the issues after wildfire caused water contamination that you need to be aware of is that there's hazardous waste scale contamination in the water potentially. So bathing in that water, trying to treat it at home, using it for cooking. Don't tell people to boil the water because it would be like having a hazardous waste and telling them to boil it, and it's indoors and such. So the health officer knew this and issued a warning to the entire county that included the utilities and others. And people, basically don't do anything with it because we know that the contamination is pretty bad. And here's some of the numbers. I showed you a little bit before about benzene, but there was a bunch of other chemicals that were present. And there's a theory out there that benzene's the indicator contaminant for all chemicals, which is not based on science or an understanding of chemical principles. It's based primarily on policy decisions and cost. People, don't want the recovery to cost too much. So if we just tell people just look for one thing, then that is easier on them. But the fact of the matter is we don't have that understanding right now. And so doing a full VOC screen and looking for these other chemicals is important. Plus, looking at the data from Paradise and elsewhere, and even Oregon, shows us now that benzene is not the indicator and that it's more complicated than that. So multiple methods and tests are necessary. Many people are asking where the contamination is from, and we believe that it's a combination, depending on the system. When you lose pressure in your hydrants and they're broken, you may have ash and debris and smoke sucked into the hydrant. That mixes with the water, leaches chemicals into it, you have contamination. The other thing is the direct thermal degradation of the plastics that are in place. And in 2020, we did a study where we took actual buried water service lines, new ones, and we heated them up to 200 degrees C. So wildfires can get up to 800 to 1500 degrees Celsius. We only looked at about 200. And we did find, in fact, that just that simple heating process generated benzene and a whole bunch of other VOCs that could then leach out into water. So we did prove that this could be a source of contamination. Now, something else you need to think about after wildfires is that when you flush out all the contaminated water, remember your infrastructure is likely still contaminated, like the plastics. And so you have to then put clean water in there and then leach out that contamination into that clean water, making it dirty, flush that out and do it again, and do it again. And so California was asking, how long is this going to take? And with the US EPA, who had a mathematical model for diffusion of these chemicals from one of the pipes called HDPE, we basically were able to calculate, under certain conditions, if you find, say, benzene in the water at this concentration, we can back calculate that it would take, a certain time period of constant flushing the water. So this helped them make decisions because they didn't want to be flushing forever, but they also didn't want to say everything's fine, and then, 2 weeks later find out that there's contamination above safe limits. So this is the process here, and you can watch this video online, but stagnation is key. So you just can't take water samples. You have to wait for the water to sit in contact with your infrastructure, which is an absolute pain and doesn't really help, to speed up things. But right now, there's no way to speed it up. Technology's not there yet. So we went out to California, and not only did we help people, the engineers, the scientists, the public health officials, and elected officials and staff, but then we teamed up with community groups and helped them better educate their community. So during disasters, you generally see community groups pop up in self-assemble. And then these groups are, they're trying to figure out how to get through the disaster and the recovery themselves. And they become kind of a source of information. And so we can partner with these groups and kind of did, hands-on activities and demonstrations about how to take water samples, how to read a lab report. What does your plumbing look like? Many people were rebuilding and they wanted to know what certain materials were and why things cost so much or so cheap. Now, if you're trying to figure out what the exposures are to people in homes, you don't want to wait 8 months or 11 months before you do testing. And so after the campfire, we recommended to California that they address the utility issues, right? Help the utilities get on their feet, but the utilities can't be responsible for going into everybody's home too, because they don't have the staff and they don't really understand the indoor plumbing, right? So you would need a separate effort to do that. California did not believe that that was something they wanted to do, so they didn't. And then a researcher at the University of California, San Francisco, got funding from a federal government and went in and subsampled several homes. Now, one of the key findings here, in my perspective, is 11 months later, they still found benzene in people's homes. So, this recovery can be very, very long. Number two, while they did take samples at certain locations and buildings, if you don't understand, where you're taking samples from and the materials in the building, and there was a do not drink, do not boil order, right? Because people were concerned about inhalation. Well, they removed the do not boil order, but they never sampled hot water systems to determine if it was in the hot water systems versus not in the hot water system. And in prior disasters, we've seen in the US that hot water heaters sometimes had to be completely removed because of the chemical uptake into the plastic dip tube and all sorts of other stuff. So there's some issues with going into people's homes and sampling. Now, excuse me, water safety attitudes was a big issue, and I can send you a copy of this study if you'd like. Please feel free to contact me. But basically, if you're in a home or your friends or family are in a home that's impacted by wildfire around them, right now in the US, they're kind of on their own in terms of water safety in the building. And that's because there is no kind of guidance for people to understand what to do. But we're changing that. So, for example, the state of California told people to go buy, they could go buy in-home treatment devices, and that will fix all the problems. Well, as it turns out, we tested, some of the devices that people were using, telling us that they were using, and it doesn't. So why doesn't it? Because these devices are not designed for chemical disaster scenarios, right? So the water treatment devices that are certified for moving VOCs often are certified for moving 15 parts per billion of benzene, not 1,000, not 300. And so it's important to recognize, if you're a utility or a public health official, when you tell people to do something, what is that something certified or validated to do? Because the concept of activated carbon is good, but not all activated carbon systems perform the same. Now, there was a number of other lessons learned after the campfire and even after these Oregon wildfires in 2020 and then even this year. State health officials told people after the campfire to smell the water, not test it, to determine if it was safe. They actually issued a press release about that. And so I would say, yes, some chemicals may have an odor when the exposure may not be safe, but we never want to be telling people or our customers, if the water smells okay, everything's fine, because we know that there are acutely toxic chemicals that you can't smell, and that's, you know, people know that too, so they get confused when somebody tells them to smell the water. There were no water restrictions in several utilities, and I don't know how it is in Canada, but in California, in other states, there is no requirement to notify the public when there's contamination in the distribution system. If the point of entry to the distribution system meets compliance purposes, then the only way that the state, the agency, would require the utility to do something is if they invoked a component of the U.S. public notification rule. But states generally don't do that because it locks them in and they have to like follow steps after that. So, so there was probably about 3,000 people that were on contaminated water systems that were not told that the water was contaminated repeatedly, and that was a problem. And then many of the decisions that were made here by in-home treatment and how homeowners were going to address their issues with their contaminated systems were actually made by insurance companies, not USC, EPA, or the state or the health department. So in 2020, Oregon had some issues where they responded to wildfires. California had some issues. This was the year after, 2 years after the Camp Fire. And what happened was many of these regulators were trying to figure out like how to test. They hadn't really done the background on like what happened in the Camp Fire. And unfortunately, what happens in the US is some information that wasn't credible started getting passed around to different states. Like benzene's the only thing you have to look for. So, you know, Oregon basically started off a little wobbly, but then, you know, got their feet on the ground, and utilities and the community have really come a long way since then. Excuse me. But what I want to show you here is the Oregon fires data. In some of the public water systems that were tested, you know, they did find benzene at some of the systems, but they also found a number of other chemicals, and some of them above acute exposure limits when benzene wasn't present. And so really that's the takeaway here is there's a number of chemicals present, and using a certain VOC, SVOC testing approach, you can find them. But again, if you don't look for these things, you won't necessarily know if they're still in your system or if they were to begin with. So, you know, kind of in conclusion, you know, knowing what we know, you know, how should we proceed with, you know, well testing or plumbing inspection or utility water main testing? And we created 2 fact sheets that we posted at plumbingsafety.org. And this goes into detail about, you know, what to look for during inspection, what type of tests you should run, considerations about laboratories, and it pushes the reader to the public health department, because sometimes the public health departments have operational ground, you know, understanding of what's going on for their situation. So we put that together. We also, you know, one of the kickers is when you're looking at water testing in buildings, you need to understand that there's trunk and branch systems, and then there's like manifold PEX system. And here's a trunk and branch system where the water comes in through the point of entry system. It might go in through like a water softener or something, and then it goes through the trunk and then branches out throughout the building, right? So if you're going to determine if the kitchen sink has contaminated water in it, that water has to go, you know, from the point of entry all the way to the kitchen sink. Same thing with the bathroom shower. That water would have to go through that entire trunk and then up to the bathroom shower. Now, for PEX systems, that's not the case. So each pipe in the PEX system goes to an individual faucet, which complicates things because, one, PEX uptakes these VOCs and SVOCs way more than some of the other plastics. And number 2, you can't really test one line and know how the others fared. So here you're probably going to be sampling the building a lot more because you want to get some idea about if contaminated water got into the building and where it is as well. So this is a PEX manifold. This would be the single lines, and all of them go. to each fixture. Something else to consider, people are going to pay money to get safe water. So if they have to be living in their home because the insurance company's not going to pay for it because they're being delivered water even though it's not safe, and they're told it's not safe, they can get trucked in water where they go to a site and fill up cans. They could get bottled water. Many people will want to do in-home treatment and like take it upon themselves to do that. That's going to cost them between $3,000 and $12,000. And my recommendation is don't do it unless you know the type and range of contaminants in the system, and the manufacturer, you get a letter from them that says this will make that water safe, basically. NSF International devices are not designed for chemical disasters. Water storage tanks, where you buy a storage tank and somebody delivers water to it, it costs a bit to set it up, and then people delivering the water as well. So there are experiences that people will have setting these things up, and right now there's really no centralized authority to help homeowners kind of navigate this situation, and even building owners. Like in Paradise, Starbucks has a building in downtown Paradise, and they bought a water tank, and as it turned out, they didn't necessarily have to validate that their plumbing wasn't contaminated before they started up again. So when we showed up, we'd done some investigation, and it had been some time, so if the contamination was there, it probably would have leached out by then. But these things you need to think about, right? Businesses want to reopen, right? It costs them money to stay closed, and so you got to think about these types of things when you're trying to repopulate a community. There's 2 documents that are now out. I just found out about this yesterday. US EPA kind of took a lot of what we had found and put together, and they put it together in like a 4-page document that talks about VOC contamination sources, sampling analysis, addressing issues. And this is for utilities in the United States. So this is, that is the intended audience. So it's worth taking a look at. And then the Oregon Health Authority put together some guidance for private well owners because they were aware that private wells could be impacted too. So the fire could burn over the well, or you could have materials go down the side of the well casing if it's cracked, and a whole bunch of other issues. There's a new building water course here at Purdue that's online. It's a short course. Feel free to contact me if you'd like. It is meant to be conducted on your own time. It's self-paced. There's no meeting times and such. And it's basically to help people get a basic understanding of building water systems. So if you're a utility or public health official and you'd like to learn a little bit more about this type of building water systems and how they're made and how they're designed, how they operate, this course can help. And with that, I would say thank you very much. And I'm happy to take any questions if you would like.
Thank you very much, Andy. That was really informative. And we really appreciate that you've been available to do this presentation. So I have some questions. If you have a few minutes, Andy, that'd be really great. If you could take some questions. So question number 1 I have here is, this water is contaminated. What do you do with the contaminated water?
That's a great question. So I can tell you what happened in California. And then maybe I think this needs to be addressed by regulators as well. So when you find 40,000 parts per billion of benzene in the water plus other chemicals, and 500 parts per billion is the RCRA federal hazardous waste limit in the U.S. You have a problem. And so what I was told was that the water is not considered a waste until you discard it. And so this is what I was told by a regulator. So if you're telling people to flush that water into their home, it is not a waste until it goes down the drain. And so there is no regulation for it. Now, I was told that because the regulator said this is going to make things very complicated if we follow it down and think more of this. That needs to be addressed. I would say flushing, 10,000 or 1,000 parts per billion of benzene plus contaminated water into people's homes, not a good idea, because you have VOCs. In even at room temperature, those will volatilize into the air. And now we're talking about trying to predict exposures in the home. In 2014, there was a chemical spill in West Virginia. The utility and the state and the public health department told people to flush contaminated water into the home, and some people passed out in their bathrooms and such, they said, because they're overwhelmed by the fumes. So something we need to think about is how to get the contaminated water out of the buildings, and so to protect the homes and businesses from receiving that. And I think that's where the utility really needs to lean on the regulators, and the regulators need to recognize the speed at which those decisions need to happen.
Okay, thank you. I have another question here. Would it be cheaper and safer to replace significant portions of the system to at least give people a centralized point to get clean water while you manage clearing the remainder of the system from chemicals?
I can see that to be a good idea under certain system configurations. I can see that. One of the issues, though, in Paradise, we put a plan together for Paradise about how to march through the system and test and replace. And then politically, that was untenable because people at the bottom of the system that wouldn't be gotten to for several months had believed that was inappropriate, right? So they wanted to be addressed tomorrow. And so what Paradise did checkerboard recovery, where somebody in the middle of the system says, I want my, area around me fixed. And so they fixed that, even though there was still maybe contamination kind of moving around. So it's complicated when you get into the political public policy decisions, but from a science and engineering perspective in logistics, it would make sense to do a centralized approach.
Thank you. Any thoughts on changes that should be brought to the plumbing code for future construction that would facilitate water quality testing after wildfires?
Yes, I would say we know plastic materials are flexible, inexpensive, and really allow us to do things that we couldn't necessarily do with metal and other types of materials. So they're good on that sense. The issue, however, is that they are vulnerable to heat and generating contamination. And so, buried water mains are probably not an issue because they're just so deep buried in the ground. But, service lines that enter the meter box, and the meter box is generally near, in the U.S., metal mailboxes and shrubs that can catch on fire. So having those, a certain setback distance away from, those types of property owner devices is a good idea. And then recognizing, there may be building code considerations. So I don't think that we're there yet, but, forget the wildfire, for structure fires, kitchen stovetop fires. Nobody, it turns out, has looked to see if you have a kitchen stovetop fire and a plastic pipe behind the wall and it takes heat damage. There is no testing post kitchen stovetop fire of the water system. So I think that's something that we may be looking at in the future.
Okay. A few more questions. Do you know of any mobile treatment plants that can be deployed to run the hydrant flushed water through to remove high levels of contaminants?
So that's a great idea. And for the last 10 years, I've been talking with utilities and federal agencies, state agencies about that. I think under extreme situations, that would have to happen. Just thinking about, radiological situations and stuff, you wouldn't be able to allow radiologically contaminated water to go into a building. So forget the wildfire stuff. There would be a need for deployable treatment systems to do that. And so I'd love to talk to people who are interested in finding a way that to happen.
Okay. I'm going to ask this as a combined question. The first part was, would flushing into the wastewater treatment system be a good emergency option? And related to that, would you expect any effects on the wastewater treatment plants from these levels of contamination?
Right. So I would say in Paradise, for example, they had septic tanks. They had like 10,000 septic tanks, no gravity sewer. But in other water utilities, they did have sewer. I would say I do not see any problem with flushing that scale of contamination as long as the regulator is aware. I don't see any issues like what happened in North Carolina several years ago. I think there was chloridane or something. They had some like hydrophobic pesticide that basically stuck to the walls of their wastewater treatment reactor and maybe inhibited growth in their bioreactors. But for these wildfire type issues where you're just talking about, contaminated drinking water, I don't see that as an issue as long as you don't flush out your bugs.
And there are 3 questions related to this. I'm going to put them together. You talk about plastic, chemicals leaching from plastic. What about any leaching from copper pipes or ductile iron, or any of those safer?
So we haven't seen, when you heat up copper and then you expose it to water, we haven't seen any difference in scale of copper leaching. So I don't know, under all situations, I don't know if that's accurate, because you could have a very corroded, ductile iron pipe or something. Under those situations, you might see scale release, and predominant. Plus, when you depressurize the system, not on purpose, but when you lose pressure, and the firefighters are fighting fires over here and dragging the water, and then going over here and dragging the water, and it gets depressurized, you may have scale release. So that's a potential problem post fire for metal infrastructure.
Okay. And I think I might just make this the last question before we let you go, Andy. Did chlorine react with the contaminants?
Good question. We believe that free chlorine will react with some of the organics released. We do not know if free chlorine will cause greater levels of DBPs in a heat-damaged water system. That's something that we're looking at.
Okay. Thank you very much, Andy, for joining us. And you've mentioned a number of resources. If we could connect later on, and if you could send them to me and the YouTube link as well for the video, then we would have those available for our delegates. So once again, thank you very much. This is an emerging field, and your expertise in this and sharing that information is very much welcome. Thank you very much.
Thank you. Happy to help.
I'm just going to stay here for a couple of minutes to introduce 2 speakers who are going to be giving an update on the work of Operators Without Borders. So we are going to do this kind of a hybrid version here, because one speaker is here and the other one is in Ontario. So Valerie Jenkinson is the chair of Operators Without Borders and has led teams on water utility recovery post-disaster. She's part of the WASH group and holds certificates in disaster coordination. Last year, she was named the focal point of the year for Global Water Partners Caribbean in recognition of her contributions to the water industry in the Caribbean. Valerie is also the CEO of World Water and Wastewater Solutions Limited and has worked with national and local governments, the EOCP, the Ministry of Health, and BCWWA, primarily undertaking stakeholder consultations and writing strategic and communication planning documents. She spends half the year in the Caribbean when COVID permits. working on climate mitigation measures for water utilities, rate analysis and operations. And joining Valerie today from Ontario is Jason Menk, who currently works for the Ontario Clean Water Agency in the region of Waterloo, where he oversees operations and maintenance at 6 facilities. He completed a 3-year environmental technology course, gaining his environment technologist diploma. He also holds a ticket as a Red Seal Interprovincial Industrial Mechanical Millwright. Jason was one of the first operators to step up and volunteer for Operators Without Borders. He was deployed to our first disaster assignment in Dominica and then led a team in response to Hurricane Dorian in the Bahamas. He also sits on the deployment committee. Jason is also the spring director for a nonprofit football association with the region of Waterloo. Thank you very much, Jason and Valerie. Over to you.
Thank you, Kavna, and a great thank you to you and your board for the support that ever since we started this Operations Without Borders that EOCP has given to us. It has been outstanding support and we are grateful beyond measure. One thing with Jason now also sits on the board of directors of Operators Without Borders, so that he was nominated and voted to the board at our AGM in May. So congratulations to Jason. So today we're going to go over some things that some of you might have seen before, because there's a lot of new people. Congratulations to the EOCP on a fantastic conference and really increasing the membership. So I thought we would go back a little bit for those of you who haven't seen one of our presentations before and tell you a little bit about what we do. And I'm going to have Jason come in and talk to you about the disasters that he has been in charge of in developing countries. It's very interesting to me, the speakers that you've had this morning with Andrew, because he's talking about wells and water quality in wells and the water distribution system. And Jason has a lot of experience doing that with the disaster we faced in Abaco in the Grand Bahamas. And of course, yesterday you had Greg Selecki talking about disasters, and you've got a panel discussion this afternoon. So disasters is on everybody's mind. But I ask you, if you woke up tomorrow morning and you turned on the tap, didn't work, you went to the toilet, didn't flush, well, that's something that isn't just happening in disasters in developing countries. And that's why we have 2 mandates. We have one mandate to assist water utilities recover from disasters, but our second mandate, because we have so many wonderful volunteers like Pat Miller, who sits on as one of our volunteers, and Kalpana, who's on our board, Heather, who helps us in many, many ways. So we decided we're not going to lose the expertise and the capacity we have and the skills that we have. So we also do skill training, capacity building. We go in and help utilities in non-disaster situations to do better than they're doing. So we go in and we give them free training. We're developing a lot of SOPs. I'll talk to you a little bit about those type of things in a moment. But I'm going to just pass over. Let's see how we go forward. Next, there we go. So 1.25 million. Nice big figure. Because I'm just doing a proposal to the Canadian government to get some funding to do some training in South America, not for our volunteers, but just for the expenses. We run a very, very lean operation. As Kalpana knows, as our treasurer, we've never had more than about $18,000 in the bank. And so when I'm doing these grant proposals, they say, well, you're not really big enough. How can you run a big budget if all you've got in the bank is $18,000? So I went back and I started adding up all the volunteer hours that we have. And that's a very conservative figure. $2.5 million worth of services that we have donated to developing countries, both in disasters and in training. It's quite remarkable. We've only been going for about 3 years, but our 60-odd volunteers have produced this much work. And we are getting so well known in Caribbean. Everybody knows OWB. I'm no longer Well Water and Wastewater Solutions, I'm OWB. We are invited to the Ministers' Conference. We are invited to take part in all of the discussions in the Caribbean. We are getting to be well known in other parts of the world as well. So in South America, we just did Incident Command System disaster training. Greg and I put that together, and Greg did the training for 12 countries in South America. So we're expanding our reach, which COVID has allowed us to do. And this is the neat thing about COVID. It's the same as conferences. You might not get 500 people coming to a conference, but when you can log in from wherever you are in the province, you come. Well, it's the same with the services that we can provide. So that is an amazing figure. So I'm going to turn it over to Jason, because he has become one of our 2 lead operators in going to disasters. He leads the teams that goes to these disasters and helps recover. So Jason, I'd like you to talk a little bit about what you've been doing. We've got some slides as well, which I'll go through. We've got one little video that some of you will have seen before, but I think it's worth showing to talk about the type of devastation that we see. So Jason, if you want to take over from here.
Perfect. Hi, everybody. I hope you can hear me fine and see me. It's wonderful to have you all here today and discuss a little bit about what we've done. This is a picture of Dominica before we went in, and unfortunately they endured a substantial hurricane that took out virtually 95% of the homes have been hit and buildings have been hit and affected by this hurricane, and essentially it washed the river right into the main city of Roseau, and this is what you're seeing here. And so there was big efforts, and luckily this was all cleaned up by the time we got there. We got there about 3 months after the initial storm, and what we did was we came in to kind of help and facilitate getting their infrastructure back online. They hadn't had any running water, or their sewage system hadn't been up and running for a number of months prior to us getting there, three months actually. So we came in and we worked with the utility, and we were able to get all the pump stations and the plant within the city back up and running within 2 weeks. And we also offered training to the people that worked there, because there was a lot of equipment that they weren't fully trained on, or just didn't understand little bits and pieces of it. So we were able to give them in-depth training into how all their equipment worked.
Jason, how do we differ from other NGOs, like UNICEF is there, Water Mission is there? How do we differ?
Yeah, I was actually really surprised when we got there that UNICEF and Water Mission and a number of other people were there, and they had been trucking water around and getting water to the people in the small communities that didn't have any running water. So myself, I went into the main city and worked on the wastewater treatment plant, and another one of our operators went up into the hills and got the water up and running. So they actually got the infrastructure up and running. We worked directly with the utilities on site to help them provide better quality water or wastewater that they don't even have when we get there. So it's actually, we're not getting them the emergency water within trucking or bottled water. We're bringing it to them back in their pipelines.
Okay. I'm just going to show this video for those of you who haven't seen it before. If we can cue up this video and show this. This is in Abaco, where Jason was in Grand Bahamas. And so this is the type of thing that we were dealing with. So if we can play that video. So back to you, Jason. There you are.
Yeah, this was a very different storm. It came and sat over half of the island, like they explained it a bit like a lawnmower, where it just kept coming back in and hitting them over and over again. And so the Grand Bahamas, their water supply is in very shallow wells, and they have hundreds of them all over the island that they supply the island with. And what happened was the sea level raised during the storm because of the low depression, brought the sea level up quite high, some places 15 to 20 feet. And all the salt water got inside their freshwater wells. So they had water coming out of their taps, and they were able to flush the lines, but it was all salt water. They weren't able to drink it. You can imagine start rusting out some of your stuff, and how nice it is to take a salt shower every day. So what we did was we went in and we developed a plan and started testing every single well on the island. And we would find out where some of the higher salt levels were and the lower ones were. So then we would turn the wells on and off, or identify them, because some power lines would be down to them. So we made up a portable pump that we would go and test each well. And even in an old section of the island that they hadn't been using the wells in a long time. And it turned out that they had some of the best water in those locations. So we were able to then start a protocol for all of the operators that came in afterwards, and we would test each well and bring on the cleaner wells and turn off the dirty wells and let them recharge. And if we had to purge certain wells, we would do so that way too. But we also helped with the infrastructure. We went into the plants where it wasn't safe for operators to go in, and we would remove all of the hazards and then bring in and make sure that all the electrical was okay, so they're not in there walking around open wires. The good thing, like Val said, we do this with the utilities. So we were able to contact the hydro utility and say, hey, we need this pole brought back on, or we need this station to have new power supplied to it. So we have a lot of pulls, so to speak, where if we're there and we can get a piece of equipment up and running and we identify it, we make it safe, the utility will come in and bring everything back online. So the picture just previous to this that I was standing in, it was a sea can that we worked with Water Mission to get online. So they had wells that were functioning, but they were full of salt. So it was in front of a school that we took a bunch of RO units and we built them into a sea can, and we used the existing well that was there to push it through the RO units, and then we filled up tankage of water, and they would truck it from there around the island. And we actually set up at that location a place for the students to come and get water every day. It was wonderful. They could walk up and they actually had a tap that flowed with fresh water. And it was also a place where locals could come and fill up jugs if they needed to. And it was something that we were very grateful to be able to work with this other organization, because they had the equipment, but they weren't just quite sure how to put it all together. So in a matter of a day and a half, we had a portable water desalination area set up that they could deploy to other places. After it was used there, they could move it to a different part of the island or whatever they needed. So it was a completely different storm, but they were so devastated and they were so thankful that we were there. It was really wonderful to be a part of, and that we were able to help get them. So we went in for a couple of weeks, and then we had multiple groups going after us for weeks and weeks to just keep continuing on what we had set up in the first place. And as you can see from the video that Val had produced, there was complete devastation. This was a lovely young family that we met, and we gave them some work gloves, and I had never seen somebody so happy for a pair of work gloves, because they could go help their grandmother.
Yeah, the house was completely destroyed, wasn't it?
Yeah.
So Jason, we're an organization basically of operators helping operators in disasters and in developing countries. Why would you recommend people get involved and volunteer?
Well, it's something that we take for granted here, is running water, and the knowledge that we have. We can take and change people's lives. We can go in and with simple operations that we do day to day, we can help get facilities back online and get people water coming out of their taps again and have fresh water. It's very, very rewarding, to say the least. Personally, I take a lot away from it, and I know a lot of the operators do. And even just to be able to go for a couple weeks and help out the people, I still talk to people from everywhere that we've been deployed. They're so thankful, and we develop lifelong relationships, and it's a wonderful thing to be a part of, and I really strongly believe that for something as simple as becoming a member for $50, it can go such a long way.
And that's $50 for 3 years, not 1 year.
Yes, not annually. Sorry, not annually. Try.
The bargain.
Yeah, no, it's definitely life changing, not just for us, but for everybody that we're a part of. And they continue years later. I continue to talk with them, and they're always bothering me to come back. Not bothering me, I shouldn't say it that way.
So talk a little bit about the type of why we do training there. You've had the experience of working with these people. They're smart, they're dedicated, but
yes. But unfortunately, they don't always have the training on the equipment. Some of this equipment is very technical oriented, and they haven't had the experience with them, or they don't get the proper training. One gentleman that I talked with, he didn't know how to run the equipment because who he had taken it over, the gentleman had passed away. So the experience was never passed on. And he was worried because I went to him and I said, hey, this hasn't run properly in multiple years. And he was worried that he was going to get in trouble. But we said, no, we want to help you. Let us show you how it's meant to be run. Let us show you and give you the contacts of who you need to contact even when we're not here. So you can learn how to run these pieces of equipment properly. Because unfortunately, sometimes the training isn't passed down from one employee to another.
And there is very little training altogether. I talked to one wastewater operator that I met on the street. He was working there, and I said, how long have you worked for the utility? 29 years. How much training? 1 day. Not 1 day a year, 1 day in 29 years. So we are offering completely free training to anybody who wants it in a developing country. We've been doing exam preparation. We've had 3 exam preparations, one on wastewater treatment, water treatment and water collection. We've had about 30 people go through these courses as an initial group, wrote the ABC exam, which is run by the Caribbean Water and Sewage Association, same as the EOCP runs it here. And so we've made a start, and we're going to be continuing this because we want to get certification. We want to pass on the skills that we take for granted in our operators that are trained. We want to pass this on to those people so that they can make their a lot more efficient. 24/7 water is not the norm there. And when we run short of water, we just turn the taps off down there. So we want to try and help them be a lot more efficient in their utilities. So we've done a lot of technical training. We do almost weekly webinars. Kawasa, the association down there, puts on a weekly webinar. And I'm the person who basically gets in the speakers. So I've been looking at the speakers here and thinking, that would be a good one for the Caribbean, Beg, Borrow and Steal. So we probably have supplied at least half of their speakers. After where Jason was in Dominica, the lab was destroyed for the utility, so they weren't able to do enough testing, etc. They built a new lab. The general manager, a friend of mine, Bernadette Enoff, said, we don't have the skills to run the lab. Can you help us? So we ran a 10-week course online. Everything's virtual right now, and train them every week. We'd love to go down there and work with them for 2 weeks, hands-on. That's by far the best thing we can do. And as soon as COVID's over, we'll raise the money and we'll send trainers down. But right now, we were able to train them so that they can start running their lab. They can start doing the testing. We can assure people that the water is safe. There's one of the pictures, Ron Enns from Vancouver, works for the city of Metro Vancouver. Yes, Metro Vancouver. And this is him training 120 employees in teams in Belize. Did a fantastic job. And there is no safety training down there. When I say no safety, I mean just basically none. And the things that you see as you go around, you shudder. So the general manager here had said to me he'd had to make a phone call to a mother of a young fellow who'd been caught in a trenching and excavating. And she's screaming at him, "My son's dead, my son's dead." He says, "No, he's not dead." He wasn't dead, but he could well have been. He said, "And I never, ever want to make that call again and have another mother in so distraught." So let me tell you very quickly a little bit about one of the biggest projects that we've got going right now. So apart from all the massive amounts of training that we're doing, we are partnering with Rotary to provide clean water to all of Haiti. So the program is Hand Wash. And as I say, it's partnering with Rotary, and they have about 12 or 14 clubs, 22 clubs down in Haiti. But there's a massive undertaking. And we are there to help them build capacity. Madeleine Bouchler, who's on our board, runs our chair in governance and has an education background, is helping put standard operating procedures together for them. We're doing an engineering internship. And I'd like to see eventually us doing an operator internship as well, so that these people are trained. We want to not only get the systems running, but also get it to be sustainable. Barry Rasson, the ex-Rotary International president, said, "Our dream is to bring portable water and good sanitation to the entire country of Haiti, 10 million people. Water is essential for good living conditions, and the people of Haiti deserve to have it." So this is the people just lining up with their buckets to get water. They say here half of Haiti's water and sanitation infrastructure does not function. I think it may be higher than that. I know we're running 90% leakage. That's not a mistake, 90%. This is one of my really favorite slides. This is a lot of the wells. So everything is on well water in these areas. The green, and you can't see, you have to look carefully to see the green. They're functioning wells that are providing water. Yellow is wells that are not functioning. Red is all the wells with E. coli. And that's what we're going to change. As you all know, there was another earthquake. I was down there after the first earthquake. It was absolutely horrendous. This one wasn't as bad, but in the certain small towns it was as bad. One of our members is in Lakai. He's a doctor. His surgery was destroyed. His home wasn't. But he said, we can't even get to places right now. So the earthquake caused a lot of damage. This is in Lakai. This was the cathedral. That is the cathedral now. So this is a 10 to 20 year billion-dollar project. And we are really, really proud that we're part of that. And we can't wait to send people. It isn't just COVID, it's dangerous there right now. The gangs are controlling a lot of the areas, and we cannot ever risk the safety of our operators. That's my number one concern, is safety of our operators. But by 2030, this is our goal. It's a really audacious goal. But if we fall short, we're still going to make it so much better in the areas that we have worked in. So as you can see, Operators Without Borders is down there as a partner, along with the big guys, Rotary Club, Hope for Haiti, North Water, some Water Mission, really big organizations. And then there's little Operators Without Borders who is making just huge inroads and helping them in that. So how can you help? Jason, you're talking about become a member. Go ahead.
No, I was going to say exactly that. Become a member. It doesn't cost much, $50 for 3 years, and it goes such a long way.
Yeah, volunteer. If you are interested in volunteering, you will. Every volunteer you ever had said, "When do I go back?" If you have a background in training, we need trainers. I don't want to burn out the wonderful trainers that we have. So if you have a background, if you've done any training, even at the basic level, please volunteer with us. Let us know that you're a trainer. Help us set up presentations like this. This is how we raise our money, is talking to people, having people join as memberships. So we need you. The operator for operators, that's what we're all about. That is you. So please come and join us. And thank you again to the EOCP for all of their help.
Thank you very much.
Valerie. I don't know, can the AV team give Valerie a microphone so she can help address some questions as they come up? But first of all, I just wanted to let you know a few things. As Valerie mentioned, I'm on the board of Operators Without Borders, and I'm one of the founding directors, and EOCP is a founding partner of Operators Without Borders. Did you want to grab that spot? That'd be perfect. Thank you. So a few things I just wanted to mention was when Operators Without Borders was founded several years ago, the OCP decided that Operators Without Borders would be its preferred charity to support at conferences and at various, in terms of helping with regards to updating websites, website information, and so on. Why is this? Why did we choose Operators Without Borders compared to any other organization? One of the reasons is it's fairly easy to give money to groups that go out and fund other groups to basically go do the work. What's unique about Operators Without Borders, it gives us an opportunity to have operators like boots on the ground helping in the countries where the help is needed. So that's one of the reasons. It's a really wonderful opportunity for operators to provide support, to contribute, and also learn from their experience. As a result, one of the things we've also decided is that, and the awards committee of the EOCP will work with Operators Without Borders. We are going to fully fund 3 operators to go on Operators Without Borders' next mission to the Caribbean.
That's incredible. Thank you.
And just to kind of let you know, it is a very lean organization. I know, I've been involved. And as treasurer, I was a little bit surprised because I was there putting together income statements and balance sheets. And I hate doing balance sheets. And submitting information to the Canada Revenue Agency, all sorts of things. So it's a very lean organization. And when we talk about fully funding 3 operators, that'll cover their airfare, it'll cover their per diems, and the per diems are usually pretty low because Valerie, if she is there, she'll cook for them. And the host country...
I'm not going to guarantee that, Keltner.
Well, I said if you're there, you quite often do. And the host...
survive.
And yeah, and I heard no complaints. So, and the host countries typically provide the accommodation. I do have some questions. One of the questions is, one of the questions, I think it's okay. Can we get the volume turned up on the presenters? But I think it's okay right now. Are all your operators certified? Your volunteer operators?
All of the operators are certified. We do have other professional water people. So Greg Selecki is not a certified operator. He has a background in utility work, but he's our disaster specialist, and he is certified at the very heaviest, the highest levels of certification. So I'm not a professional operator, certified operator. Keltner's not a certified operator. But all of the people that you see, like Jason, are certified operators, yes.
Okay. And I have another question here. What percentage of your volunteer operators are female?
That's a really good question. Our board is actually more female than male. So we have a good gender balance on that. It's similar to the industry. We do have a number. I don't know the exact numbers, Keltner, but we do have probably the same representation as we have in the industry. It is still a male-dominated industry. The grant proposal I'm doing right now is to help developing countries attract more women into the industry. So we've got a whole recruitment of women and training for women specifically to enter the industry.
Okay. I have another question, and I could answer, but I'm going to leave it to you. As a volunteer, am I responsible for the loss of income when abroad, and how is employer support?
Great question. We do not pay the operators. They are volunteers. Generally speaking, they take their holidays to go. In certain instances, they can approach their utility, and their utility will sometimes at least match them, if not give them the entire time off. And we say, you've got to go for 2 weeks, because we can't really afford 2 sets of airfares to send people for 2 weeks rather than sending them for, once. So we do pay all the expenses, but we don't pay for your time. we do encourage the utilities to at least match or give people the time off and keep them on the insurance as well. That's the only thing we have is operators do bring out their own insurance.
And last I have is not a question, but it's a comment. It's from Dan Skidmore.
Oh, hi, Dan. Get well soon. Dan had a slight stroke and is off work right now, and he's one of our wonderful volunteers who was working in Belize with us, and so we're sending you all the very best, Dan.
So the comment from Dan is absolutely the best experience I've had volunteering in Belize and Barbados. So thank you very much, Dan, for that comment, and that helps us close the session. And we have a bit of a break right now, and 10:15, the 3 different streams will be starting off. Thank you very much.
Thank you, everybody. Look forward to seeing you as a volunteer.